Algebra 211, 5.3, Multiplying Polynomials, by the talented but humble Mr. Gordon. Remember, when you add polynomials, basically all you're doing is collecting like terms. However, if you're subtracting polynomials, you will want to rewrite the subtraction as addition of the opposite. When we are multiplying polynomials, it's basically the same process that you use to multiply monomials with the rules that we've just learned for exponents. And you might remember something like, if we have 2x, a monomial, times the polynomial x plus 4, we can do use the distributive property, okay? And that'll give us 2x times x, 2x squared, and then 2x times positive 4, which is 8x. A common mistake that students do when they are multiplying polynomials is they get this answer here, 2x squared plus 8x, and then they turn right around and they factor out the 2x, that's the common monomial factor here, and basically you're right back where you started. And I've had actually students leave that showing. Don't do that if the directions are multiply, stop with the product. Okay, for our next example, consider a binomial x plus 2 times another binomial 2x plus 1. Again, everything here is being multiplied since there are no symbols between the two polynomials. Okay, this is our good old friend FOIL. Okay, so we need to multiply our firsts, then our outer pair, then here above I'm going to mark it our inner pair, sorry for overlapping here, and then even a little bit higher our lasts. Okay, so our firsts are x and 2x multiplied together, that becomes 2x squared. Our outside pair is 1 times x, which is x. Our inside pair is 2 times 2x, I'm going to go down here, which is 4x, and then our lasts, the 1 and the 2, gives us 2. And so we do have 4 terms currently, but if you notice, these two terms are like terms. And so we can combine those again just like we did in the first part of 5.3. And so our final answer here is going to be 2x squared. X plus 4x is 5x, and then plus 2. Okay, now we get into something where we have perhaps not seen it quite as simple before. A binomial, x plus 4, times a trinomial. We'll put a term negative in here just to see how that would behave. Okay, this is what I call modified FOIL. The definition of multiplying polynomials found on the top of page 347 says this: you multiply each term of the first polynomial by each term of the second polynomial. Whereas we did that with FOIL before, we now don't have just one outer and inner pair, one first and one last. So basically we're going to be looking at multiplying this way, and this way with the x. Okay, and then we're going to go here, here, and here with the 4. So each term of the first polynomial, once with the x, once with the 4, is multiplied by the 3 terms of the second polynomial. I will not be showing vertical multiplication as you might see in example 3. I prefer that we would work horizontally. It actually eats up less space and is a little more convenient based on our already learned FOIL pattern. And so everything that I'll do will be the horizontal format like you see right here. Okay, so let's take a look at the red lines that I wrote up there with our first of the first polynomial by all 3 of the second polynomial. So we have x times x squared, which is x cubed. Then I multiplied x by the 3x term, which would be 3x squared. And then the x gets multiplied by the negative 4, producing negative 4x. Now we move over to the 4, and it gets multiplied by each term of the second polynomial, as marked by the green lines. So 4x squared and then 4 times 3x, that's 12x, and then 4 times negative 4, which is negative 16. One thing that might help you as you add your like terms here is to go now, I'll do it in brown, and underline all of the like terms. Here are the x squareds and the x squareds. I did not underline the x cubed because there is only one term with x cubes in it. Then I have some x terms. I underline those twice. And then there are some 1's. And so I can underline those 3 times. And we have all of our like terms separate. Not underlined, underlined once, underlined twice, underlined 3 times. So we will now combine those. The x cubes, that's our highest degree, and there's only one of them, so it's in the answer. With the x squareds, we have the 3x squared plus the 4x squared, making 7x squared. Just watch your sign here. You have to be careful with the term's sign. You'll see that with the next one. Here are the 4 x's that are negative, and 12 x's here that are positive, so that's like doing 12x minus 4x, which leaves a positive 8x. And then finally, the negative 16. And there is your product. Okay, the next type of problem that you deal with in terms of polynomial multiplication is if there are 3 polynomials together. And maybe in this case you can see here 3 binomials. The easiest way to keep track of these is to look at the first 2, do the normal FOIL on these since they are both binomials, and then we'll multiply that answer by the other. Okay, so we have the first, x times x, x squared. The outer pair, x times 2, that's 2x. And then the inner pair right here, negative 3 times x. So I have positive 2 times x and negative 3 times x. 2x minus 3x is negative 1x. And then our last, negative 3 times positive 2, is negative 6. So there's the product of the first 2 binomials. And I'll just bring down the x plus 6. Okay, and we are back to this process that I have called modified FOIL. And this time I'm going to show you the way I normally write it, which is just to do the first term with the first term, x cubed. First term with the second term, 6x squared. That's using up the x squared with both of the others. Now I move to the negative x. Watch your sign. Negative x times x, the first one here, negative x squared. And then negative x times positive 6 is negative 6x. Finally, we move to the negative 6, and we multiply by x to get negative 6x. And then here, probably should have drawn these lines, that might help. Negative 6 times positive 6 is negative 36. You can see that there. Okay, so again, as I did before, we have some like terms. I'll go ahead and underline those for reference. Okay, and now it's just a matter of combining like terms. So our final product here, x cubed, 6x squared minus x squared is plus 5x squared. 6x and 6x, both negative, make negative 12x, and then minus 36. Okay, and that is another completed binomial times a binomial times a binomial. Okay, the last part of this multiplication lesson deals with a couple of special product patterns, and these are found on bottom of page 347. The first one is called the sum and difference. I usually just call this the difference of squares. You learned this when we were factoring. We started with the end result here that I'll write at the right, and we were working backwards to have the sum of squares, and then, or the sum of the two terms, and then the difference of the two terms. But what it produces is actually a difference of squares, a squared minus b squared, and that's because the outer pair, negative ab, and the inner pair, positive ab, cancel out. So all that we really have left are our first and our last. Okay, the O and the I went away from FOIL. There is an example to the right there on page 347. I'll have you look at that one. It's very straightforward. Then you have your perfect squares, okay, binomials. A plus b quantity squared. And these are commonly enough occurring that you want to memorize them to the best of your ability and not have to constantly do the FOIL process when you write this out. But if you're ever stuck, it's a certain, this is an exact result of FOIL. To square means to have two factors of that multiplied together. And so when you do your first, outside, inside, and last, you get your a squared. Here's your outer pair, ab, inner pair, another ab. So there are two factors of ab. And then your lasts, of course, plus b squared. If that happened to have been a minus sign, then again we can write it out, a minus b times a minus b, and FOIL. And the whole process, the whole point of learning these special products is to not have to write them out like I'm doing here, but to simply go right to first, a squared, outer pair, negative ab, inner pair, negative ab, for negative 2 ab's total. And then we have in our last positions, negative b times negative b. So now we have a negative b times a negative b, which is a positive b squared. So the only difference between above and below now, these two perfect square binomials, is the middle term. Positive 2ab up there, negative 2b down here. If you study the bottom of page 347, cube of a binomial formulas, it's just going through the process that I just did on the prior slide, where you have three binomials multiplied together. A plus b cubed would mean a plus b, a plus b, a plus b. Okay, we're actually going to learn a shortcut for that later on, and so it's not really necessary here to spend a lot of time with that shortcut. It involves the Pascal triangle, and we will definitely be making good use of that later. So we're going to, for now, if you encounter a cube like this, write it out and do the modified FOIL method that we have just learned. Okay, to practice your comfort level, you can look at the guided practice problems on page 348. This is number 3. X plus 2 times 3x squared minus x minus 5. And test to see how well you understand this new modified FOIL example and process. So if you want to take a minute and try that and see if you can come up with the correct answer, maybe look at 4 and 5 as well, especially 4. We'll see how much more help you might need. Okay, now that you've had a chance to test yourself with a few of those guided practice problems, to finish out the section, we need to look at example 6 on page 348. If you've had a minute to look it over, study their solution, they have done their multiplication of these two features or equations, the horizontal, or the vertical method, sorry. I would not do that, and as we're going to see, it's actually not necessary to multiply the two together yourself anyway. I want you to remember that we have the ability with the calculator to put products right in there. And so in this problem, you're dealing with petroleum being produced from 1980. The W formula is in thousands of wells producing crude oil, and then the O formula represents the average daily oil output per well. And so we're trying to find from all of the wells the daily output. So we need to multiply all of the wells, W, by the output average, O. In the calculator, it doesn't care if you've already done the product and just enter that, or if you just take your Y equals here and put in the two equations. So we'll use parentheses to keep them separate. Negative 0.575. We don't have t, so we'll use x squared, plus 10.9x plus 548. Okay, Just remember that this T here represents thousands, or this W I should say, is thousands of wells, not just one well. Okay, I'm going to put a multiplication dot there because I need to change lines. I'm going to change colors here just to represent the O. This is the formula for the amount of oil average. And so now we would enter negative 0.249 x plus 15.4. Remember, x here is the number of years since 1980. Okay, it's t in the equation in the book, but we have x in the calculator. So if we've entered this whole thing in the calculator, it's actually finding the number of wells times the average daily output of oil. So we have what we're looking for right here. Our question that was asked in this problem is, what would be the average total amount of crude oil produced per day in 2000? Okay, and so in terms of using this at this point, the easiest thing to do, what I call the TOV method, is to now pull up a table that represents all the x and y values for this. 1980 was year 0, so 2000 would be year 20. So we're going to go look up in the table when the x value is 20, find the respective y value. As you look at that table, you should be able to find out that the y, hold on here, I've got a problem with my screen. As I was saying, you should be able to find that your y is 5,585 by 585.1. However, remember from this problem, always double check your units here. These W values were in thousands, so this is actually in thousands. So our actual answer here is 5,585. Now we move the decimal place 1,000 3 places to the right. There's 1, 2, 3. And these are gallons, I believe. I'm looking for my unit here. And I'm not sure it says. So we'll have to check on that. Bring our freeze back. 5,585,100 is our answer. Okay, I looked back at the example a little bit closer, and it's not gallons, it is barrels. Barrels of oil. So 5,585,100 barrels is the average output per day for the year 2000. Of course, it'd be interesting to see how that would compare to 2013. Lastly, I will finish by saying good luck. Yeah, let's try luck. As you multiply these polynomials and do your work with this, I appreciate your patience as I have gone through my first lesson here online like this, recording myself. I apologize for the monotone voice and the mistakes that had to be corrected along the way. Hope you'll be patient with me as I learn to do this even better. Good luck.